Joe here has sent in a message asking me how he should graph a function from a rule.
Okay, so you want to graph a function from a rule. Well, actually, graphing a function from a rule is a lot like graphing one from a table. In fact, the easiest way to graph a function from a rule is often to make a table. So let's actually do that here. Let's use x and y. There we go. Actually, you know what, let me get a different, go to another layer here. There we go. And then we'll draw a line down this way and see what happens as we pick different values for x. Let's do 0, I'm sorry, 1, 0, -1, 2, -2. How's that? I try and pick numbers on both sides of 0 usually because if your graph is going to do something funny, it often does it right around 0. So let's try these numbers first and see what happens. If I plug 1 in for x, then what I'm doing is saying what happens when this is my input number where x is in my function. So I put 1 in here. I put 1 in place of x and I get 4 times 1 plus 1 equals y. Well, 4 times 1 is 4, plus 1 is 5, so 5 equals y. So if x is 1, y is 5. What happens if I plug 0 in? Well, then I'd get 4 times 0 plus 1 equals y. Well, 4 times 0 is 0, plus 1 is 1, so if x is 0, y is 1. If I plug in -1, I get 4 times -1 plus 1 equals y. 4 times -1 is -4, plus 1 is -3, so y then is -3. If I put 2 in, I get 4 times 2 plus 1 equals y. So I get 4 times 2, which is 8, plus 1, that's 9. So 9 is y. And if I put in -2, I get 4 times -2 plus 1. So 4 times -2 is -8, plus 1 is -7. So then I get -7. So here's a series of values that I've taken from this function rule right here, and I've calculated when I put a number in, what number comes out from that function. Now I just need to take these points that I've found and put them on my graph. And remember that x is the horizontal and y is the vertical. And let's actually do 2 per notch here. So let's label these 2, 4, 6, 8, 10, 12, so we can get out some of our bigger numbers in there. And we'll leave the x, well, no, we'll do the x by 2s also, why not? 2, 4, 6, and so forth, just so our graph is square. So if x is 1, then we're halfway here, and y is 5, so we're 1 1/2, so we have a point right there. If x is 0, y is 1, so it's half a step up. If x is -1, y is -3, so it's right there. If x is 2, y is 9, so it's right there. And if x is -2, y is -7, 2, 4, 6, 7. So it's right there. So we can see all these dots are in a line here. If we draw a line through them, like something like that. I don't know why my lines lately haven't been showing up, but they sure haven't. So if we draw a line through them, we can see then, and maybe what I'll do is just draw over that line. We can see then that all these things line up. And with anything, any number in this, on this line, in this straight line, any point on that line is going to represent a pair of numbers. So if, for instance, there's a point right here at 13, 13 on the y, and 3 on the x, then we should be able to put 3 in for x in our equation over here and get 13 out. Well, 4 times 3 is 12, plus 1 is 13. So that works. So we can see that we can actually draw a line from the points, or we can find points once we've drawn the line, as long as we draw the line accurately. But that's how you graph a function from a rule. You just put numbers in for x, find out what numbers you get out for y when you do that, and then plot those pairs of numbers on an xy graph.